You are looking at the night sky. You think you're looking out. You're not. Every telescope pointed at the stars, every radio dish scanning for signals, every equation written to describe the cosmos, all of it is aimed at something that may not be what it appears to be. The universe has a surface. It has rules. It has a speed limit and a beginning and an expanding boundary no one can see beyond. And the more precisely we measure it, the more it looks like something that was designed to be measured. These are not fringe ideas. These are peer-reviewed theories published in the most respected journals in physics, and not one of them is comforting. Section 10. The universe is inside a black hole. Every black hole that forms in our universe consumes matter, collapses it, crushes it past the point where the known laws of physics apply. What happens inside, past the event horizon, is mathematically undefined. In 2010, theoretical physicist Lee Smolin formalized a hypothesis called cosmological natural selection. Each black hole, when it forms, does not simply destroy what falls into it. It spawns a new universe on the other side, a universe with slightly different physical constants, slightly different rules. Our universe, by this model, is the interior of a black hole that formed inside some larger parent universe. The Big Bang, the moment our universe began, is, in this framework, the moment the black hole that contains us finished collapsing. What makes this hypothesis deeply uncomfortable is that from inside a black hole's daughter universe, you cannot see the parent. You cannot measure the boundary. You cannot detect the event horizon that contains you. You would see exactly what we see, a universe with a finite age, an expanding boundary, and a set of physical constants that appear fine-tuned to allow the existence of complexity. Fine-tuned, because they were, by natural selection. Across trillions of generations of universes, we are not the first universe. We are not the last. We are a child of a black hole that is itself a child of another. Section 9. The dark forest theory. In 1950, physicist Enrico Fermi asked a question over lunch at Los Alamos. Where is everybody? The universe is 13.8 billion years old. It contains 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. The conditions for life are not rare. So where are the aliens? The most optimistic answers involve distances and time. The most terrifying answer was formalized by Chinese physicist and author Liu Cixin. He called it the dark forest. Imagine the universe as a forest at night. Every civilization is a hunter moving through the trees. No hunter can know if another hunter is friendly. No hunter can take that risk. Because in a universe of finite resources and unknown intentions, the only rational strategy upon detecting another civilization is to destroy it immediately, before it detects you, before it grows, before it decides you are a threat. Under this logic, the galaxy is not silent because there is no one there. The galaxy is silent because every civilization that survived learned the same lesson. Make no noise. Leave no trace. Destroy anything you find. The silence of the cosmos is not emptiness. It is the sound of civilizations that have already understood the rule and are following it perfectly. The first signal we ever successfully broadcast into space was in 1974. The Arecibo message, a 168-second transmission aimed at a star cluster 25,000 light-years away. Astronomers celebrated. Carl Sagan helped design it. Under the dark forest theory, it was the worst thing we have ever done. Section 8. Hidden alien megastructures. In 2015, astronomer Tabitha Boyajian published a paper about a star 1,400 light-years away, catalog designation KIC 8462852, now known as Boyajian's star or Tabby's star. Tabby's star dims, not in the smooth, regular, predictable arc of a planet crossing in front of it. It dims by up to 22%. A planet the size of Jupiter blocks only 1%. And it dims in patterns that are irregular, asymmetric, and non-repeating. It also fades slowly over years in a way no known natural phenomenon explains. The leading hypothesis is a swarm of comets. It is also the least satisfying hypothesis because the math doesn't fully work. The hypothesis that fits the light curve data most precisely is a Dyson sphere, A megastructure built around a star to capture its total energy output, not a complete shell, a swarm, an incomplete construction. A civilization mid-build. We have now cataloged several other stars with anomalous dimming profiles that match no known natural cause. We are not saying they are megastructures. We are saying the data is consistent with megastructures. There is a difference, but it is a smaller difference than it was 10 years ago. Section 7. The Moon is artificial. In 1970, two Soviet scientists, Mikhail Vasin and Alexander Shcherbakov, published a paper in the journal Sputnik titled, "Is the Moon the Creation of Alien Intelligence?" They were not asking metaphorically. Their argument rested on documented anomalies. The Moon's moment of inertia suggests its interior is less dense than its exterior, the inverse of how a naturally accreted rocky body forms. When struck, the Moon rings with sustained resonance, suggesting hollow internal regions. Its orbital geometry produces geometrically perfect solar eclipses, a coincidence approaching zero probability by chance. The consensus explanation: the Moon formed from debris ejected when a Mars-sized body called Theia collided with the early Earth 4.5 billion years ago. The giant impact hypothesis. It explains the Moon's surface composition. It does not fully explain the moment of inertia anomaly. It does not explain the acoustic hollow signature. It does not explain the eclipse precision. Science does not require an artificial explanation, but science does not yet have a single model that accounts for all the data simultaneously. Vasin and Shcherbakov's paper was never peer-reviewed. It was also never fully refuted. Section 6. Black holes are portals. In general relativity, the mathematics of a rotating black hole, a Kerr black hole, do not predict a singularity at the center. They predict a ring singularity, and the equations describing what happens to matter that passes through that ring describe emergence into a region of spacetime with different coordinates. Not destruction, passage. Physicists call these solutions wormholes, Einstein-Rosen bridges. They are real solutions to Einstein's field equations, not approximations, not metaphors, mathematically valid. The problem is stability. A natural wormhole would collapse faster than any object could traverse it. But in 2019, physicists at Caltech and Harvard proposed a mechanism involving quantum entanglement, the ER equals EPR conjecture, suggesting that entangled particles are connected by microscopic wormholes at the quantum level. And if microscopic wormholes exist, they can, in principle, be scaled. We have not built one. We do not know how. We do not have the energy. But the equations allow it. And in physics, what the equations allow has a way of eventually becoming real. Section 5. Time moves differently in space. This is not a theory. This is a measured fact. GPS satellites orbit Earth at 20,200 kilometers altitude. At that altitude, gravity is weaker. Weaker gravity means time runs faster. The satellites gain approximately 45 microseconds per day relative to clocks on Earth's surface. Without correction, GPS would drift by 10 kilometers every day. The correction is applied constantly, built into every navigation system on the planet. Einstein's general theory of relativity predicted this in 1915. He called it gravitational time dilation. Near the event horizon of a supermassive black hole, one with a mass equal to Sagittarius A star, the 4 million solar mass black hole at the center of our galaxy, the effect is not microseconds. 1 year at the edge equals billions of years for the rest of the universe. Civilizations could be using black holes as time machines right now. Not science fiction. The physics permits it. We are the ones not doing it yet. Section 4. Most of the universe is invisible. In 1933, Swiss astronomer Fritz Zwicky measured the velocity of galaxies in the Coma cluster. The galaxies were moving too fast, far too fast to be held together by the gravity of visible matter alone. He proposed the existence of unseen mass. He called it Dunkel Materie, dark matter. For 40 years, no one took him seriously. Then Vera Rubin measured the rotation curves of galaxies and found the same anomaly everywhere. The outer arms rotate at the same speed as the inner arms, which is only possible if they are embedded in a halo of invisible mass extending far beyond the visible disk. Today, the confirmed breakdown is this. 5% of the universe is ordinary matter. Atoms, stars, planets, you. 27% is dark matter. 68% is dark energy, a force driving the accelerating expansion of the universe whose nature is entirely unknown. 95% of everything that exists cannot be seen, detected directly, or identified. We named it. We mapped its gravitational effects. We have built our entire model of cosmology around it. We have never touched it. We have never seen it. We do not know what it is. Section 3. We might be living in a simulation. In 2003, philosopher Nick Bostrom published a paper in the Philosophical Quarterly, now known as the simulation argument. The logic is clean. One of three things must be true. Either virtually all civilizations destroy themselves before reaching the capability to run ancestor simulations, or virtually all mature civilizations choose not to run such simulations, or we are almost certainly living in a simulation right now. In 2022, physicists at the University of Portsmouth demonstrated that the mathematical structure of quantum mechanics, specifically the way information is processed at the Planck scale, the smallest possible unit of space, is consistent with the information structure of a digital computational system, not metaphorically, mathematically. Fermilab ran an experiment called the holometer, 2 years of measurements searching for fundamental pixelation in space-time, a graininess that would indicate a discrete computational substrate beneath reality. It found nothing, which means either we are not in a simulation or the resolution is higher than we can currently measure. Either answer ends the conversation before it starts. Section 2. Space signals could be artificial. On August 15, 1977, astronomer Jerry Eman was reviewing data from the Big Ear radio telescope at Ohio State University. He found a signal, 72 seconds long, narrowband, occupying an impossibly thin slice of the radio spectrum, exactly the profile of an intelligent transmitter, centered on 1,420 megahertz. The hydrogen line, the frequency every physicist agrees a transmitting civilization would choose because hydrogen is the most abundant element in the universe. Eamon circled the printout and wrote one word: wow. The signal has never been detected again. In 2016, a strong signal was received from the direction of HD 95128, a Sun-like star 94 light-years away, strong enough to trigger a formal SETI protocol. In 2022, researchers at FAST, the 500-meter aperture spherical telescope in China, the largest radio telescope ever built, identified 8 candidate signals formally flagged as requiring further investigation. As of today, none have been confirmed as natural, none have been confirmed as artificial. They are simply there, repeating from the same coordinates, at regular intervals, without explanation. Section 1. Humanity may already be observed. The Voyager 1 probe was launched in 1977. It is now 24 billion kilometers from Earth, the farthest human-made object in existence. At the speed of light, a signal from Voyager takes 22 hours to reach us. The Milky Way is 100,000 light-years across. A civilization on the other side of our galaxy, one that has existed for 1 billion years longer than us, would need a radio telescope only marginally more powerful than Arecibo to detect our television broadcasts. We have been producing detectable electromagnetic signals since 1900. That signal shell is now 124 light-years in radius. It has reached approximately 18,000 star systems. Some of those stars are 8 billion years old. Some of the planets around them have had longer to develop civilization than the Earth has existed. The dark forest theory says they would destroy us. The zoo hypothesis says they are watching, waiting for us to reach some developmental threshold. The planetarium hypothesis says they have already surrounded us with a carefully managed illusion that what we see when we look at the cosmos is a controlled display, not the actual universe. We cannot rule any of these out. We cannot rule any of them in. What we know is this: the universe is very old. It has had enormous time to produce intelligence, and the silence, despite all of that time, is profound and total and unexplained. Someone may be watching us right now the way we watch a species before we decide whether to make contact, and they have not decided yet. The universe is not empty. It is not silent because there is nothing there. It is silent in the specific way that a room full of people goes silent when something important is about to happen. Everything we have measured, everything we have built, everything we have launched into the dark points at a reality that is stranger and older and larger than any story we have told about it. Subscribe. The next one takes you somewhere you cannot come back from the same.